Async await, probably one of the best things that has happened to JavaScript, but it's something that TypeScript hasn't quite fully solved. Sure, it's nice, you can mark functions with async, and now you're delegating them to the event loop, and then you can just await those asynchronous functions. Or well, you can just omit await entirely if you want this function to be run in the background and you do not care about making it synchronous code. But I've decided from now on to never use async await ever. And the reason is because it is incredibly unpredictable. I'm not talking about making it synchronous. All you need to do is await them, and now it's asynchronous code in the guise of synchronous code, but I'm talking about the success and the error channels. Take this line for example. We say await response.json. Now we're only worrying about the result, and that is the to-dos. So we're thinking about the data. When you await something, the first thing that you will see is the data you get back. But nothing tells you if JSON can fail. So now you need to be conscious of this, and you need to wrap all of this within a try-catch block. But now the error is unknown, and that makes sense because internally these functions can throw whatever they want. And that is exactly my biggest gripe with async await. It makes you think about data first, and then you worry about the errors. So what have I replaced async await with? Well, that is with Effect. In fact, I recently made a video about it a couple of months back, and I wasn't fully convinced of using it for everything. But the more I delved into the library and all of its surrounding ecosystem, I dare to say it is a must-have library for any serious type of work. So let's see it in action. So we know that fetch can result in an error. We know that .json can result in an error, and we're getting back unknown. So we also need to parse the incoming data. So now we have, in reality, 3 types of errors, or well 4, because we need to consider the status of the response and whether or not we could actually make the request. So let's model this with Effect. So the first thing that I'm going to do is say get to-dos. That is going to return, and I'm going to import Effect from Effect. And then we're going to say gen, so for generator, and then we're going to have a generator function here so we can yield within this function. And now here what we can do is say const response is equal to, and instead of saying await fetch, what we do is say yield, and then we take in this first parameter, and here we can say effect.tryPromise. And then here we can pass in the promise, so we can say fetch. Now if I take a look at response, it is of type response, which is exactly the same as this one. So as you can see, we're not thinking of awaiting anything, we are just thinking about the computations, and that is just try promise. Now we need to filter the status. One way of doing it is using if statements. So you can say if response dot okay, so if not okay, then how can we model the error? Well, for that we can say return, and then we can say effect dot fail. And you can fail with whatever you want. I'll leave it with fail to fetch to-dos. Now if we take a look at the type signature of get-to-dos, as we can see it is returning an effect.effect that is going to result in an effect or undefined, and then unknown exception, and then never. So the first generic, so I'm going to type this out. So we have, I believe, R, which would be the result, or well, we can say success channel, error channel, and then requirements. So whenever you take a look at the signature of an effect, the first parameter is the success channel, so what it is going to succeed with. Then we have the error channel, so the errors, usually a union of different errors, and then the requirements. And this is great for dependency injection, which we'll see in a moment. Anyway, here in the success channel, we can see that it is an effect of effect or undefined. Now this makes sense because if this is okay, we're not returning anything. So that's where the undefined comes from. But what about this other effect? And well, that is effect.fail is going to return to us an effect where it won't succeed with anything, so it is never, and it is going to bring a string for the error channel and then never for the requirements. So as we can see, when we return this raw, we're passing this effect over to the success channel, which is not what we would want to do, since we want to map this over to the error channel. So for that, you need to yield this, and it is going to retrieve that error channel from fail and add it to the pipe of this effect. So if we take a look at getToDo's, as we can see, it succeeds with nothing, so undefined, makes sense, and the error type is string or unknown exception. Now what about the JSON? So we can say const todos is equal to yield, we do the same, then effect.tryPromise, and we say response.json, and we just return the todos. So when you return like this, you're passing this value to the success channel. And as we can see, the type is now unknown, string or unknown exception, and then never. So now these two are pretty much identical, except that the errors are being mapped automatically by every single effect, because tryPromise is going to return an effect of response and the error channel will be unknown exception. And same with this one. So these two are pretty much being propagated to this gen function, and that's why they are inferred here. Now, what if we want to run this gen function? How can we achieve that? Well, first of all, we're wrapping two functions, because this in itself is already a function. So why are we creating a wrapper function that is going to return a function? Well, for that, we can just omit the function and say getToDo's is equal to, and then effect.gen. Now to run this, well, you cannot just reference getToDo's. You need to run this. So you must say effect.runPromise, and then you pass in the effect that you want to run. And as we can see, runPromise takes in an effect. And well, this is using generics, so we get full type safety. Now, let's take a look at the result. We're getting a promise of unknown. So what can we do here? Well, we can await this, but this is not ideal, because now we're back to square one. Now we do get a huge benefit, and that is just by hovering over getToDo's, we know what the error channel is. We know that it can result in string or unknown exception. But the problem with using await, we're thinking about data. We're not thinking about exceptions. So what will ultimately happen with these errors? Well, since we get unknown back, that means that it is going to throw the errors, and that's what we do not want. So what can we do in that case? Well, we can change this over to say getToDo's, then we pipe this through, and we can say runPromise. So we're back to what we had, just with a different syntax. But here we can say effect.ignore. And by doing this, if we take a look at results again, the type is a promise of void. So it is not going to succeed with anything, at least not here. If you await the promise, you're not going to get back anything, but no errors will be thrown either. The two channels will be ignored altogether. And this is great, because now you need to start thinking about the errors, such as handling them and also tapping into the result. So what you can do here is say effect dot, and then you can say tap, and here you get the to-dos. So as we can see, this is unknown. So what is tap? Tap is just a way to access the success channel without modifying the success channel in the pipe. So in this case, we're tapping through to-dos, and we can do whatever we want with them. We can call another function. We can print this to the console, whatever you want. But what about the errors? Well, you can say effect.catch, and you have catch, then catch all, and then you have catch if, catch some, and so much more. But the two main ones that you will be using are tag and catch tags. So when you say catch tags, you can pass in an object, and this object will map each tag of each error to an object. So you can say unknown exception, and as you can see, you get full type safety. So you can say error and then error.message or name, cause, whatever. But what about this error here? We're throwing back a string, so we cannot match this against anything. Well, that's because in Effect, you usually model everything via tags. So tags are like the identifiers for your errors. So instead of throwing a string or null or whatever, it's recommended to throw a class that contains the tag property. So what I mean by this is this try promise will result in either response or unknown exception. And why unknown? Because since we're saying try promise and then passing the promise, Effect has no way of knowing what the error will be from fetch. It has no information for that. And why? Because this is not effectful. Fetch does not use effect. So that's why we cannot retrieve the error information. We have to do that manually. But that's great because we need to start thinking about exceptions and handling both channels, success and error. So for that, you can change this up and in fact, change this to an object, and then you can say try, and this will be this function, and then catch. So here, catch, and you get the error. Now the error is unknown. As you can see here, makes sense. But you can remap this error to whatever you want. So you can say class HTTP error, for example. And then here what you can say is public read only, and then you say tag, and then this is usually the same name as the class. So HTTP error. And then you can say catch, and then new HTTP error. And by doing this, now if we take a look at get-to-dos, it is going to return either a string or a known exception or HTTP error. So we can in fact change this to be request error. And then when we come here, we get the request error. And I forgot to instantiate this, and now this gives us the error. So as we can see, request error. So now we can access the properties of this error. So we can pass in a message, we can do whatever we want. And we can do the same for the other ones. But to avoid specifying a tag and doing this manually, Effect comes with a constructor, a class that you can extend from. So you can say extends data. So you import that from Effect, and then you say tagged error, and then request error. And by doing this, as you can see, you still get request error here, and this is fully type safe. So you get the message as well. And you can do the same for the other ones. So you can say class not okay error, and then you can say if not response okay, new not okay error. And if you take a look, you can now see not okay error. And if you come here, we also get access to that error. As you can see, it is extremely powerful. We can also add class not JSON error, and then you can fail this. So you can say try, and then when catching, we want to remap that to a not JSON error, and again we get access to this error. So just by looking at the definition of the effect, we get information about everything. And as we can see, unknown exception is now not present in the error channel. But we can improve this even further. We can parse the to-dos. So I'm not sure what we're getting back. Let me check this really fast. So as we can see, we get an array of objects, user ID, then ID, so these two are numbers, title, which is a string, and then completed, which is a boolean. So let me copy this and paste it here for reference. So now how can we ensure at the runtime that we're indeed getting back an array of this? Well, for that you can declare a schema, and that schema can also be effectful. Now where does schema come from? Well, I believe it's from @effect/schema. And if you have used SOD, YOP, whatever, you'll already be familiarized with pretty much everything that entails parsing data with @effect/schema, but it has way more utilities beyond that, and that is thinking about encoding and decoding data. so bringing back the parse data to its original state, which I'll not be delving into this video, but I will be making a video dedicated to this library. Anyway, we can say const response schema is equal to schema.struct, and then you define the properties. So user ID is a schema.number, and this is actually an integer, ID is an integer, and then string and boolean. And then we can come here and say const parsed to those is equal to yield, and then you say schema dot the code unknown. So this is the code from unknown, and then you can pass in the response schema, and this is going to return to you a function that you can now invoke, and you can pass in the data. So you can say to do's, and you can also pass in extra information. So you can say an excess property, you can say error. So if there is an excess property you want to bail out right away, or you can say ignore. That means that remove it from the result of the decoding, and then you can say preserve. So keep those extra properties. In this case, we can say ignore. And now if we take a look at parse to do's, as we can see, it is now a read-only object. So that's great. But what about the effect itself? As we can see, we now have parse error. So as we can see, when invoking the code unknown, it is going to return an effect. So here, takes in the schema, takes in the options, it is going to decode it, and then it is going to return a function that when invoked will result in an effect where the success channel will be the data from the schema. So as we can see, A, and then the error will be parse result.parse error. So by yielding this, we're retrieving the success data, but we're propagating the error channel to the generator function. So that's why we can see it here. And now we can return parse to do's. And now we can also get access to parse error here. So remember, the tag is the discriminator. So this one right here. Now when handling the errors, well, that's up to you. You can do whatever you want. So you can handle one by one, or just handle some, whatever you want. In this case, we can say catch all, we get the error. So this error again could be any of these ones. And then we can say console.log, and then we say error, or rather error.tag, and then error. And now here we need to return another effect from catch all. Now the reason we need to return something from here is because you can recover from the errors here. You could say effect.succeed, and then you can say an empty array. So in the case it is an error, we now can ensure that at line 56 and onwards, there are no errors in the pipe, because we have basically replaced any kind of error with an empty array as the recovery. Or you can say effect.fail, you pass in the error again, and now you're still passing the error down the chain. Whatever you want, that depends on your use case, of course. Now we can simplify this a little, and we can say effect.filter, and then we can say or die, or else, or fail. So we can say or else, and then we get the response, and then we can say response.ok. So where the response.ok is true, and then we can pass in another function where we still get the response, but we can also return an effect. So here, since we're yielding this, we can either succeed from this function, or we can fail from this function, which will ultimately be propagated to this generator. So you can say effect.fail, and then new not okay error. And that way we can remove this line, and we have streamlined all kind of errors pertaining to response within the pipe of response. Now I hope that you found the power of effect. I mean, it's great that you can just hover over an effect and you get all of the information you need. But one thing that is missing is typing the effects, right? I'm always of the belief that you should type everything whenever you can. Obviously, some types must be inferred. Those types are so complex, are within the internals of a library, so you cannot type that out explicitly. But in the cases where you can type something, you should do it, because if we change this, so let's say we accidentally return a string here, well, nothing is telling us, hey, you need to return this. So how can we do that? Well, we can say effect.effect, and then we pass in the type. So you can say type response is equal to schema.schema.type, then type of response schema, and then here you can say response, comma, and then you pass in the errors and then the requirements. However, I'm not a fan of typing errors. And the reason is, unless you need to enforce them somewhere specifically, they should be inferred, because you might add another error and TypeScript will not tell you, hey, you're not throwing that error, because that union is a possibility, not a requirement. So since we do not want to type out the errors manually, it is tedious and also not entirely representative of what an effect will result in, at least for errors. I like to create an identity function that will require you to specify the return type explicitly, but the errors and the requirements are inferred. So to make myself clear, if you say effect.effect response, and then you pass in the union of the errors, and then you also have the parse error, what happens if you add another error? So class no elements found error extends data.tagged error, and then you come here and say if parse_todos.length is equal to 0, and this is not an array, I just noticed that, so array of this struct, and we can get rid of this, and we can in fact do it here, so filter or else. By doing this, we now need to type it out, so we get this type error. That makes sense. So we add this error, but then after a while, we do not want to model empty to-dos as an error. We still want to return an empty array. So you say, okay, I'm going to remove no elements found error. Not from here, but from here. Now you're not returning that error anywhere within the code, but if you take a look at the program, at the effect, you still get no elements found error. And that's terrible, because this error can never actually happen. So you're losing type safety in that sense. So that's why you should never type the errors, unless of course you need to restrict them solely to those type of errors. But generally speaking, you do not need to type them out. So how can we just type the response without typing these ones? We cannot say never, we cannot say void, because if we do this, now the error is void, which is another way of saying any. So to solve this, you can use an identity function. So you can say const make effect. This is what I like to do. And then you say this will be s is equal to never. So we need to type this out. The reason why I'm defaulting this to never is, well, if you try to return anything, it is going to tell you, hey, you cannot assign something to never. So you need to pass in this generic. That's a way of enforcing this rule. And this will be a function that is going to return another function. And this function will take in E and R. So the error and the requirement. So you can say E and then R, then effect. This will be an effect of S. And I'm not sure why this is auto-completing it like that. And you just return the effect. As simple as that. A very simple identity function. And by doing this, you can now come here, say make effect. And then you invoke this once again, because this is going to return a function that expects the effect. And then all you need to do is type this out, response. And that way, you still get the power of inferring the types for both the error and the requirements channel, but you're enforcing the return type. So this is what I would recommend everyone to do. Now, you can use effect like this. You can use a schema from effect if you want to decode data, parse data with effectful functions, procedures, or you can just use effect for the error handling. So you can just use it like this, but you still wrap everything within try promise. You create your own effect wrappers, whatever, and you can still use it with await. Obviously, you can still get the type information. You can still automatically throw the errors when you await them without ignoring them, or well, replacing the error channel with a success value. I mean, you can use it without all of the ecosystem of effect. You can basically replace async await entirely with effect, but all of your other code could be written imperatively without effect. This is in no way forcing you into the ecosystem of Effect. However, I would still recommend checking out all of the utilities from Effect. You might find it that this is indeed the missing framework for TypeScript, and this is essential for all TypeScript projects because you can have retries. For example, you can say effect.retry and then you pass in the options. So you can say schedule and then you can say exponential, for example, 200 milliseconds, and then increment by a factor of 3, and then you can say times, so you can say just 3 times, for example, or you can say while the error is different from something. I mean, you can do whatever you want here. So this is great. You get retries out of the box. You get utilities like filter, but well, you can replace this with an if statement if you want. But Effect comes with its own utility, and that is HTTP, the HTTP platform. So you can say import all as HTTP from @effect and then platform and then HTTP client. Now this is in fact another library, so you must import or install @effect platform. Same with the schema, just so you're aware of that. But you can change this to be const get to-dos2 is equal to make effect response, and then you can say http.request.get, and then you pass in the URL, and then you can say pipe this through http.client fetch OK. So this is already going to filter it out for you. So here filter status OK. So you do not need to do this imperatively like we're doing here. And then you can say effect.retry. You can pass in the options, and then here we can say times 3. And then you can say schedule.exponential if you want to minimize transient errors, or you can say spaced. In this case, I always like to use exponential for those transient errors. And then http response.json. So this is going to parse it, or well, expect JSON back. And then I believe you can say http.response.json schema JSON or body JSON, something like that. You pass in the schema. I had to look this up in the documentation. I always forget about this. In fact, we should say andThen, which I'm going to show you in a moment. And you can say http response.schema body JSON, and then you pass in the response schema. And this is already doing the JSON, so this is redundant and we can remove it. And as we can see, the result is an effect. We get the data here. And for the errors, we have HTTP client error, which is actually divided into 2 sub-errors. The parse error for the schema makes sense. And then the requirements are scope. You can look that up in the documentation. It's a way to avoid basically memory leaks and whatnot. So in fact, we can satisfy the requirements by saying effect.scoped. So scope all of the computations and resources of this effect or this pipe solely to this one right here. And that way, as we can see, it is now never, and we still get back the success and error channels. And as you can see, this is way cleaner, or at least shorter, than doing this manually. Notice how many lines this spans compared to this one. So that's why it doesn't hurt to read the documentation, see what you can find there. There's a lot of utility functions for everything you can think of. Now let's take a look at this andThen, because if I come here to this type, as we can see, it has some overloads here. So not that easy to read. But if I come here and say get to-dos2 .pipe and then effect.runPromise, we can first of all catch all. So here we get the errors. So again, the error is of type HTTP client error or parse error. And if I say catch tags, we get the parse error. And then, as I said, they are divided into subtypes or sub-errors. So we have the tag for request error and the tag for response error. So response, well, when the server responds back with an error, and request error is when we cannot make the request. maybe no internet connection. But now, what about the and then? What's that exactly? Well, I told you you can map or you can change the success channel in a pipe, because I told you we have tap, which is a way to just get access to the data, to the success channel, without modifying it down the pipe. But you can say effect.map and you get the to-dos here, and you can return the length, for example. And by doing this, when you tap here, you get the length back. And as you can see, the type is a number. So map is a way to, whatever you return from here, modify the success channel. You can do this with map error, of course. But what about this and then? Well, that's because when in a map, you try to return an effect. So here you can say schema.decode, and then you can say unknown, and then you can pass in response schema or schema.struct, just an empty struct. And then here you invoke this again, you pass in the to-dos. When you do this, what you're getting back is an effect, which is not what you want. You need to flatten the effect. You need to take the parse error, propagate it to the error channel, and take the success value and propagate it to the success channel of the pipe. So for that, you need to say flatMap. So you use flatMap when you are returning an effect that you need to flatten. So retrieve the success, the requirements, and the error channels, pretty much. But what about the and then? Well, the and then does the two. So you can return an effect, and as you can see, it is going to flatten the effect, or you can just return the length. So a map, basically. So as you can see, this is a number. So the and then is combining map and flatMap. So you basically don't need to choose between the two. And that's it. So as you can see, Effect is a very powerful library, and I would recommend ditching async await in favor of this library. It is what TypeScript is missing, and this library is what makes TypeScript complete, in my opinion. Anyway, I hope you enjoyed the video. If you did, make sure to like the video and subscribe. I'll see you in the next one. See ya.